Okay, welcome everyone. Good to see you. Sorry for the delay in getting started this morning, but I can see that there's quite a few of you out there. Just like to say welcome to Michael as well from Air Maths Tuition. He's going to be answering your questions on the live chat here. So what have we got for you this morning? Well, we've got some questions a question on differentiation, log equations. Somebody asked me as well if they could have a bit of work on vectors, so I've just got a fairly basic vectors question at the moment. Also, we'll be doing some simplifying of an algebraic fraction. So hope you're ready for this, and off we go. So your first question then today, okay, is going to be this one. Just see if you can answer it. Just leave you with a few moments on that. Put your answers up, and just be interesting to see what we get. Okay, so anybody got an answer on the first one? This should appeal to any GCSE students out there, by the way. Okay, we have some answers coming in on the first one. X is 5. Interesting. Anybody else agree with that one? Yeah, we got a lot of people saying that X is 5. So good. Well done, guys, for that one. Now try the next one. See what you get. I'll just put that one up for you, save time. There's the answer. You should have been able to do that one. Get x equals 5. Okay, some interesting answers coming in here. So, okay. Right. Okay, so some of you are starting to find that this one's awkward to solve. Okay, right, well, let's just have a look at this because this raises an interesting point, okay? Obviously, some of you have seen then that if we take the left-hand side and you expand it, you get 2x minus 10. And if you take the right-hand side and you were to expand that, that reduced down to 2x minus 10. So basically, you got two results that were exactly the same. And quickly glancing at some of your results, I see that I've got answers that x equals 0 here. Well, yes, if you put x equals 0 into the left-hand side, you'll get the same result on the right-hand side, 0. If you put any number in on the left-hand side, you'll get the same result if you put it on the right-hand side. And that is because you anticipated, because of this sign here, without me saying anything, that this was an equation right from the start. And the point that I want to raise in this teaser question, if you like, is this, that if you were to put equals in, it's misleading. It tends to look like it should be an equation. And so what I want to encourage you to do is to use a different sign, this sign here, which a lot of people ask me, why do I write this? And that is 3 lines here. What I'm saying is that 2 lots of x minus 5 is identical to 2x minus 10. It's not an equation to solve. If I get rid of that, it starts to look like an equation, say something like these ones up here, these lines, okay? So you put 3 lines in, it's identical. And when it comes to this statement here, this is identical, not equal to it. So we should be encouraging you as teachers to write identical in. That's in my opinion anyway. Okay, so what I want to just remind you is that if you get a question, say, that says expand, a couple of brackets, try not to write equals there. Try and say that this is identical to this when you expand it, which in turn is identical to this expression. You're going to get this when it comes to factorising. Say factorise x plus 3x squared times y. Use your identical sign, okay? It's another way of writing this statement. When you get equations, when it says solve, or even if it didn't say solve and you see that equals there, you would most probably anticipate that's an equation. All right? Okay, so just giving you a few notes on that, because it's a comment that I get asked so many times. Why am I using this sign here? Okay, the identical sign. So hopefully that gives you a heads up on that. Okay, I'm just going to delete all these, okay, just before we go on to the next question. And the next question, I've given two questions here, one for AS level and one for A level. If you're doing A level, you might want to try both of these questions very quickly. You can see you've got to differentiate y with respect to x. Okay, so post your answers, I should say, to this one. Okay, we've got Nick coming in with an answer for A, and a lot of other guys coming in. Yeah, this is good. This is very quick. 4x plus 1, although it's not meant to be too long, that first one. Any A-level guys out there want to try the second one? We've got Rizal with an answer. Okay, good. To see some answers coming through. Okay, Gabriel coming in with an answer. Some differing answers further down here. Right, okay. So I can see that some of you guys out there know how to do the second question. The first one, we'll run through that one very quickly. Just expand the brackets in the usual way. Give you 2x squared plus x minus 6, and then you can differentiate each of those three terms with respect to x. If you do that, dy dx turns out to be 4x plus 1. Okay? Now, for this one here, okay, if you're doing A level, you tend to have to know these things, and that is the product rule. I've given it here as y equals uv in short, where u and v are functions of x. I'm going to take u as 3x squared and v as sine x. Not that it really matters, you can do it any way round you like. But dy by dx is u times dv dx plus v times du dx. Basically, you just take one part. If we think of this as two parts, you take one part, times it by the differential of the other part, and then plus, just do it the other way round. Okay? So, I don't tend to write u's and v's in. I just take one part and times it by the differential of the other part. So, here we go. If you're doing this, and by the way, just a reminder on differential of several trig functions. We're going to be using the differential of sine x in this one, which is cosine x. Okay, so if we differentiate this, I've taken one part, the 3x squared, times it by the differential of the other part. Differential of sine x is cos x, plus take the other part, sine x in this case, times it by the differential of 3x squared, which is 6x. Because we've got an addition sign here, it doesn't matter which term you write first, okay? How you approach it, okay? It's what we call commutative. It doesn't matter which way round you go. Okay, so just tidy this up. I'm going to write that 6x in front of the sine x, okay? Looks better that way. So we get 3x squared cos x plus 6x sine x. Or you could obviously have 6x sine x plus 3x squared cos x. That's up to you. Okay, so hope you got that one right. As I say, I can see some of you got that, so well done. Again, do check out my video tutorials on my website or my YouTube channel, okay? They should be there to help you further on things like the product rule. Okay, we've got another question here, moving on quickly. This is the third question then of 5 questions. So the next one up is this one on logs, okay? Solve this equation on logs. So see how you get on with that one. We did a log one the other day. This one is slightly different, okay? So give you a chance to try that. As I say, yeah, if you've got any questions you would like, topics you would like us to or me to put on in these future workouts, do write them in the comments. Try not to write them in the chat so much, purely because when this video finishes the chat might disappear. Okay, so do write any comments in the description below the video, okay, on YouTube. Then we can come back and have a look, see what you want and how you felt the tutorials are going, okay? Right, so anybody coming in with some answers for number 3 here? Take care with this one, okay? Take care with it. So the question says solve, so we're looking for you to find out the value of x, okay? It's not an identity, all right, so we know that there should be some answers here. Okay, we're going to get some answers. The answers are coming in. I see Hadi has said x equals 1. Anybody else? X equals 2 from Rahima. X equals minus 2, I should say, from Rahima. Okay. And we're getting several answers here. Minus 2 and 1 I see coming up on the screen from various people. So, okay. Now, what is the answer? I'll give you the answer. The answer is x equals 1. You've got to be very careful with this, okay? This is one of the reasons why I said this one. Let's just run through this and I'll tell you why x equals 1. First of all though, just to remind you over here, the rules for logs that you should be familiar with. We're not going to use all of them here, as you'll see, but just a revision note there for you. So what we've got to do in any log equation is reduce it down to 2 terms, always. One term on the left-hand side, one term on the right-hand side. And you can see at the moment that I've got 2 terms here on the left-hand side. So I'm going to group these together. But before I can group them together by the subtraction rule here, I need to get rid of that too. So I can use the power rule. And if we use the power rule, we end up with that 2 going up as x squared. Now, I can group these 2 terms together by using our subtraction rule here. It's the same as dividing those values. So that's what I've got here. The log in base 4 of 2x all over x squared equals the log in base 4 of x plus 1. Okay, so I've got 2 terms here. I could, I don't have to, I could subtract this term from both sides and then clean up the left-hand side. This side would equal 0, and then I could reduce it down to this kind of idea, but there's no need to at this stage. I've got my 2 terms, both terms are logs, so all I need to do is just take away those logs, okay? Not physically take them away, kind of anti-log if you like, and that just gives me 2x over x squared equals x plus 1. By the way, these x's cancel, so it reduces down to 2 over x, okay? 2 over x equals that x plus 1 when we remove the logs. So now just clean this up by multiplying both sides by x, leads into this quadratic equation, which we rearrange to make equal to 0, factorize it, make each factor equal 0, and that would lead to x equals minus 2 or x equals 1. And that was the trick here, okay? Two answers here. I wanted to see who was awake. You can't have a negative value. You can't take the log, for instance, of negative 2 here. Can't take the log of negative 4. Can't take the log of negative 1 when you substitute minus 2. Okay, so it's not a solution. You can only have a positive value. And so, therefore, x is 1 since x has to be greater than or equal to 0. Okay, so well done to you guys out there who saw that particular point. Okay, so hopefully you won't trip up on that one again. Okay, let's move on to the next one. Two more to go. Okay, this next one is vectors. As I said, someone requested vectors before, and I'm going to start to put those kind of questions in. This one, if the position vectors of P and Q are AI minus 7J. I and J, by the way, are unit vectors, and when I write by hand unit vectors, I tend to underline them. They'd normally be written in bold, okay, in a textbook or an exam paper. Okay, so we've got P is AI minus 7J, Q is 2I plus 5J respectively. Given that this thing, I'm not going to say what it is, this thing equals 13 and A is greater than 0, find A, okay? I'll tell you what this thing is later on, okay, if you haven't guessed. You should be familiar with this notation. Okay, so how are we doing on this one? Get that value of A. We've got an answer in already, and that is A is 3. Anybody else? Christopher, I can see A is 7, A is minus 3. Good to see some answers coming in. What about anybody else? Rizal, A equals 7 only. Ether, A equals 3. It's nice to see you guys out there trying this, coming up with all these answers. These questions are out there to test you, so do take care. All right. Okay, I think we'll start to give some working out to this one in a minute. Okay, let's see what this is all about. I didn't give you what this meant, okay? I was hoping that you would remember or know what this is. This talks about the magnitude when we use these symbols. This is talking about given that the magnitude of the vector PQ equals 13, okay? So that's one way of writing that. Now, okay, what is the answer? Well, the answer to this one is A equals 7. Some of you guys who put minus 3 out there didn't take note of A is greater than 0 in the question, okay? So the answer is A equals 7. Let me quickly take you through it. I've drawn you a diagram here. I find just drawing a sketch handy, okay? So I've just drawn on my vectors P, okay, position vector. I always start from the origin here. P is the vector A minus 7. You'll see I've written it as a column vector as well. You don't have to do that, but I find it's quicker. O to Q, the position vector Q, 2, 5, written as a common column vector. Okay, this diagram doesn't have to be accurate. You could draw P and Q anywhere you like. It would still be exactly the same if you join P to Q. Going from P to Q is a well-known result, this result here. O to Q minus O to P. I'll take you through that result just quickly. P to Q is the same as going down here. That's the opposite of O to P, so that's minus O to P, followed by, that would be plus O to Q. I've just happened to write them the other way around. It's a lot easier to work with rather than writing minus OP plus O to Q. Alright, so standard result, O to the last letter minus O to the first letter when you get questions like this, okay? Right, okay, so that's done. So all you need to do is write your column vectors in and do that subtraction. So if you do the subtraction between the elements here, okay, you should have 2 minus A as the I component and 12 as the J component. And to get the magnitude of a vector requires you to be using Pythagoras' theorem. And we know that that magnitude is 13, and if you were to use Pythagoras' theorem, I've just happened to draw this in for you in advance, okay? You don't need to draw this in. It's just to give you an idea of how Pythagoras' theorem is working in the magnitude. As you can see, it's the square root of the sum of the squares of these two components, which are represented by the two smaller sides of the right angle triangle, PQ being the hypotenuse. Okay, so what would I do here? I'd square both sides really, get rid of that square root sign, and if you do that, you'll get this equation. And then I'm going to subtract 144 from both sides rather than open up this bracket. Much quicker to take the 144 from both sides. Now I can take the square root to both sides. Don't forget that plus or minus for the square root of 25, which is plus or minus 5. Then if I rearrange this for A, I get A equals 2 plus or minus 5. I need to take the plus option because if I take both options, I'm going to get A is 7 or A is minus 3. A cannot be a negative number for this question here, okay? A is greater than 0, so A must be equal to 7. There you go, okay? So hope you were able to get that one. Right, last question now of this session. We're doing well, okay? I like to try and keep these to about half an hour, and this one's going to be on half an hour at this rate, okay? So, okay, let's go for the next one. Okay, it's this one here. I've given you this one. I want you to simplify this. Nice algebraic one. You might not think it's that nice, but it's an exercise more than anything else, okay? An exercise in simplifying this. There's many ways that you can do this. I'm looking for a nice quick solution. All right, so nice quick neat solution. Might take a little while, not too long I hope, but give you a few moments to try that and enter your answer, okay, and we'll see who can give us the first one. Yeah, so if you've joined us just later on in this session, welcome. I've got Michael here who's answering in the chat some of your comments, and good to have you along. More sessions coming, by the way, every weekday, 10 o'clock. Although this weekday, I will say, I put down to do a tutorial on Friday, but forgetting that it's Good Friday here, I'm going to cancel that one, and the pure maths workout is going to be on Wednesday of next week. Tuesday of next week, I'll be doing a mechanics one, okay? So I hope you'll be able to join me there. So, yeah. Anything else I can say at this point? Not a lot, obviously. Okay, so how are we doing out there on this one? No answers yet. I call this type of question a stacked fraction one. It's something that I get asked about quite a lot, how we simplify these kind of things. Right, we have some answers coming in now. Okay, so interesting ones from you guys. Yes, some good, interesting results coming through, I can see. Manav has x minus 3, Amy minus 16 over 3x. More coming in. Notice we're getting some answers here. Interesting variations. Okay, if you have a look. Okay, well done guys for having a go. Let's see how your methods, shall we say, compare with the way I do it. When we're doing questions like this, okay, what we're doing, I mean, some of you might be taught, you know, turn the fraction upside down and multiply. Fair enough, but we're A-level students now and AS students. We should be beyond that kind of idea. What we're doing is basically trying to find the lowest common multiple of these fractions, x plus 4x, and the denominator here, x minus 4, x plus 4. We need to get rid of these fractions, okay? So what we do is we take the lowest common multiple, which is going to be this x, an x plus 4, and an x minus 4. And we multiply top and bottom of the fraction by that, okay? And this value, because we're multiplying top and bottom by the same value, this is like multiplying this fraction by 1. And so it's not going to change it, it's just going to change the appearance. So when you multiply this through, let's show you what you get, okay? It simplifies, okay, quite a lot. Because you should find that when you multiply this with the 2 over x plus 4, the x plus 4's cancel, just leaving you with 2x bracket x minus 4. When you multiply this term, okay, with the top line there, the x's cancel, so you're left with 3 times all of x plus 4, x minus 4. And then when it comes to the bottom fraction being multiplied by this, you can see the x minus 4, x plus 4's just cancel out, so it becomes x times x. I know you would write x squared in there, but I'm just leaving this color-coded to help demonstrate this point. Okay, so all you need to do now is just expand the brackets out or not. And you'll notice that to save time, I've noticed that x minus 4 was a common factor between these two terms, okay? And if we're simplifying something, we want to try and reduce it down in the number of terms, okay? So rather than expand out, I've decided to take x minus 4 as a common factor. So you'll see that you've got 2x minus 3 times all of x plus 4 in these square brackets here, okay? Over x squared. So I can just clean up the inside of this, 2x minus 3x, that's going to be minus x, and I've got minus 3 times 4 is minus 12. So I'm going to get this result, which I did notice some of you guys had out there. You could argue this is not necessarily the cleanest result. I could take negative 1 out here, okay, and just pull my minus 1 out, and I'll be left with x plus 12 in the bracket, which to me would be a cleaner answer. So if you do that, I've pulled that minus out the front here. And what you could also go on to do is you could take that negative sign back into here and reverse these as 4 minus x. So I believe I've done that down there, okay? So in my opinion, this is one of the nicer answers. Well done though if you got this one, got it down as far as this. Well done if you spotted that you could take that minus back into this one. But any of these answers are going to be good, okay? So there you go, all right? So I'll just come back on now. Do take your time. If you come back on these video tutorials, you might want to try them again. Obviously pause the video and have another go, okay, between these sessions. Right, okay, so yeah, that brings us to the end now, just a little over half an hour, and hope you enjoyed that and got some value from it. Thanks to Michael for helping out once again on the chat. Michael from Air Maths Tuition. So hopefully see you guys tomorrow. I'm going to be doing my first statistics workout tomorrow. So if you're into statistics, I'll try and devise some nice questions for you to try. And don't forget to give us a thumbs up if you like this. Also, if you could write any suggestions in the comments, not in the chat so much, okay, because we won't necessarily see that when it gets deleted. So do write any suggestions in the comments. Great to hear from you. Yeah, have a good day. See you for now. Okay, bye.